this lesson, we are going to learn about trigonometric ratios. And when you hear the word trigonometry, it should immediately make you think triangle. Trigonometric, triangle. Trigonometric ratios are relationships that compare the sides of a right triangle to an angle. So in this case, we are talking specifically about right triangles. And we want to compare two sides of a right triangle, and that has a relationship to its angle. And that's going to have something to do with this image right here. Maybe it helps you think, say, so, ka, like crow, ka, toa. And we're going to find out what that means. So, in a right triangle, the longest side is the hypotenuse. And then we have two other sides that are called legs. So no matter which angle we're talking about, the longest side is always the hypotenuse. And that's always going to be across from the right angle. Then we have two other acute angles, and I'm going to call this one angle theta. You can actually do this from either angle. And then from that angle, we have the opposite side, which goes straight out from that angle, doesn't actually touch that angle, isn't part of that angle, it's the opposite side, and the other piece that is part of that angle is the adjacent side. So from that, we can make ratios of right triangles, and we give them different names. So the sine of an angle A, looking at this triangle now, sine of angle A is the length of the side opposite. So angle A, opposite angle A is the side that's not touching it, the length of the side opposite, divided by the length of the hypotenuse. And again, the hypotenuse is always the longest side, always the side across from the right angle. So we write that, instead of writing out sine, we just write S-I-N. Some students say sin, but it's always pronounced sine. So this is sine of angle A is length of the opposite side, in this case that's little a, divided by the length of the hypotenuse, that would be little c. So in this triangle, A is across from little a, B is across from little b, C is across from little c, and C is the right angle and little c is the hypotenuse. So sine is the length of the side opposite divided by the length of the hypotenuse. When we put numbers in, it looks like the next triangle. So I have angle A, opposite angle A, so straight out from angle A is side 3. 4 would be the adjacent side, and 5, the longest, is the hypotenuse. So if I want to find the sine of A, again, that's the length of the side opposite, so opposite A, 3, the side that's not touching A, over hypotenuse, length of hypotenuse, longest side, 5. And we're just going to leave those as fractions most of the time. Every once in a while we want to turn them into decimals, but pretty much we're going to use them as fractions. So sine of angle A in this triangle is 3 over 5, opposite over hypotenuse. Now we can do the same thing with angle B. So sine of B is going to be the length of the opposite side of B. Sorry, it got disappeared. So here's angle B up here. Opposite B is the side not touching B, not part of B. So in this case, the opposite side from B is 4. And the hypotenuse, still the length of the hypotenuse, is 5. So same triangle, but two different sines, depending on which angle we're talking about. Sine of A, 3 over 5. Sine of B, 4 over 5, because the opposite sides are different depending on what angle we're talking about. So this is opposite B. 3 is opposite A. So that's one of our trigonometric ratios. We have two more trigonometric ratios, depending on which sides we're talking about. So we have cosine of angle A. Cosine of angle A is length of the side adjacent. Remember, the adjacent side is part of that angle, over the length of the hypotenuse. And the tangent of angle A is the length of the side opposite, divided by the length of the side adjacent. So the tangent doesn't use the hypotenuse. So we can use these to find other trigonometric ratios. So using this triangle over here, which is the 3, 4, 5 triangle again, says find the following. So cosine of A, so I identify, here's my A. Cosine, length of the side adjacent, so that's the one right here, right next to it, so that's the length of the side adjacent is 4. Cosine of A, length of hypotenuse goes on the bottom. Hypotenuse is going to be the longest side, is going to be the 5. Tangent of A is going to be the length of the side opposite. So we'll start with the opposite side, which is the 3, divided by the length of the side adjacent. Well, that's the one that we used already. That's the 4. So my tangent ratio is 3 over 4. Cosine of B. Well, B is up here. Cosine says length of side adjacent. So I'm going from B. Adjacent to B, part of B is right next to it. Adjacent is the side right next to it that's actually part of it. So 3. And cosine of B has the length of the hypotenuse on the bottom. The hypotenuse is still the 5. And the tangent of B, we're still thinking B, but opposite side, length of side opposite B is the 4. And length of side adjacent is 3. So you'll notice that there is some repetition. A lot of the numbers get used again. The sine of A is equal to the cosine of B. The sine of B is the cosine of A, because the side opposite B is adjacent to A. And tan of A and tan of B are just the flipped over fraction of each other. They're not exactly the same, but they're flipped over. So other than writing this out every time, cosine of A is the length of the side adjacent over the hypotenuse, and the tangent of A is the length of the side opposite over the length of the side adjacent, people came up with a trick to help you remember what the trig ratios are. So that trick is SOHCAHTOA, which says the sine of any angle is equal to the opposite of the angle over the hypotenuse. So S equals O over H. The cosine of any angle, that's what the C stands for, equals the adjacent side over the hypotenuse. So C equals A over H. And the tangent of any angle is equal to the opposite side over the adjacent side. So T equals O over A. So if you remember this SOHCAHTOA, that will tell you which sides we're using in order to write the ratio. We're using the opposite and hypotenuse to write the sine ratio, the adjacent and hypotenuse to write the cosine ratio, and the opposite and adjacent to write the tangent ratio. And those SOHCAHTOA, we're going to write them a lot. You're going to have them memorized pretty fast, and they are going to help you to know which ratio to use in different situations. And that's where this original image came from, SOHCAHTOA. So maybe that helps you remember. If you see the sewing thread, the crow, and the toe, maybe that'll help you remember SOHCAHTOA. Kind of sounds, I don't know, we always said Indian when I was growing up. So thinking about this triangle now, we want to find sine A cos A tan A. So sine A comes from So sine A is going to be opposite over hypotenuse. So I go to A and I say opposite. That's this one right here, little a. Hypotenuse, little c. Cosine A, well, that comes from ka, not ka. So cosine of A is equal to the adjacent side. So from A, the adjacent side is B over hypotenuse C. And TOA, to give us tan, is going to be tan of angle A equals opposite side. So from A still is little a over adjacent side is little b. Okay, so SOHCAHTOA, they help us to write out the trig ratios for any given triangle. And the whole reason that we have trig ratios, or one of the reasons that we have trig ratios, is that they actually let us find missing sides in a triangle. If we know a side and an angle, we can find a missing side. So we need to use a graphing or scientific calculator for this, and I've got my scientific calculator over here to make sure your calculator is set for degree mode. If you're not sure how to do this and you're getting the wrong answer as you follow along with the examples, then ask me in the next Zoom lesson and we'll figure out how to change over yours. So in mine, I go to Setup, and under Angles, I've got several options. I've got degrees, radians, and gradians, and so I'm going to stick with degrees. I want this to say DEG. That's what I'm looking for. And that'll give me the correct answer. So for each of these next examples, I want to find the missing side, and it's telling me to the nearest tenth. So that's what I'm aiming for, nearest tenth. So looking at example number 1, I have the angle 35, the side 13, and the missing side A. So every time I start out, I'm just going to write out my TOA, because that's going to help me figure out which of these I'm going to use to find my missing side. And my focus angle is this angle that they've given me, this 35 degrees. So looking from this 35 degrees, the A is actually my adjacent side. It's the side that's part of the angle, right next to the angle. This is my adjacent side. And 13 is across from the 90-degree angle, so this is going to be my hypotenuse. So when I'm looking at SOHCAHTOA, I want a trig ratio that uses adjacent and hypotenuse. Sine uses opposite and hypotenuse, so no adjacent, get rid of that. Cosine uses adjacent and hypotenuse. Look at that, that's the one that I want. Can ignore TOA because I still don't have opposite, so I'm going to set up my CA ratio, so CA-TOA. So CA tells me the cosine of my angle, the cosine of 35 degrees, is equal to my adjacent side, that's my A, over my hypotenuse, that's my 13. So I put in the information that I know from my triangle using cosine adjacent over hypotenuse. And then from there, before I can type this into my calculator, I need to get the A by itself. So in order to do that, I'm going to multiply this 13 off the bottom, because if I multiply both sides by 13, the 13s will cancel. So I've got 13 cos 35 equals A, and I'm going to type that into my calculator. So I'm going to type in 13 times cosine 35, hit enter, and that tells me side A is 10.64897658. I'm going to round to the nearest tenth, so 1 decimal, so that stays 10.6, and that would be my final answer. So I set up my ratio using my SOHCAHTOA, and then I solve for the side that's missing. So if I take a look at example number 2, again I'm going to write above it SOHCAHTOA, and this is a good habit to get into until you get used to figuring out which one you're using. And then again, from my angle that I'm given, which is the 53, I need to figure out what sides I have. So the B across from the 90 is going to be my hypotenuse, that's easy. And because the 12.3 is not touching my angle, not part of my angle, this is my opposite side. So I'm going to use something that has an opposite side and the hypotenuse. So if I look at sine has opposite hypotenuse, that's the one right away that I'm going to use. Get rid of the other two, don't need them. So opposite and hypotenuse, set up the ratio. So it says sine of my angle, so in this case sine of 53 degrees, is equal to the opposite side 12.3, divided by my hypotenuse. That would be my B. Now this one's a little bit trickier to get B by itself because B is on the bottom of my fraction. So I can't just divide by 12.3. That will move this out, but that won't actually get this into the numerator. So in order to deal with that, I actually am going to move the B to the other side first. So I'm going to multiply both sides of my equation by B to get it out of the denominator. So I have B times sine of 53 equals 12.3. And now to get b by itself, now that it's out of the denominator, I'm going to divide out the sine 53. I can move this all to the other side, divide this by sine 53, to give me b equals 12.3 over sine of 53. So you've essentially switched places between the b and the sine 53. That's kind of handy if you remember how that works. So multiply both sides by b, and then divide both sides by sine 53. Sine 53 is just a decimal number. If I type that into my calculator, just for an example, it just is a decimal. It's just a number. So I can divide by it same way I can divide by anything else. So when I want to figure out what this answer is, I'm going to go 12.3 divided by sine of 53, and that tells me the length of my side B is 15 point, round to the nearest tenth, 15.4. And that would be my final answer. One more example. In this last triangle, again, start out by writing so, ka, toa, every single time. That'll help you out a lot. From this angle that I have, from my 21 degrees, I've got my opposite side, which is the 41, and my adjacent side, which is the C. I don't have my hypotenuse, so if I start looking at my ratios, sine is opposite over hypotenuse. Well, I don't have hypotenuse, so get rid of that. Cosine is adjacent over hypotenuse, don't have hypotenuse, get rid of that. Tangent is opposite over adjacent. I have the opposite, I have adjacent, that's the angle, that's the ratio I want to use. So I set it up, tangent of my angle equals the opposite side, that's the 41, divided by the adjacent side, that's the C. And again, I've got the C on the bottom, I need to get it by itself, so I got to get it off the bottom onto the top, so multiply both sides by C, so that my C's cancel. So this gives me C tangent of 21 equals 41. And then again, this tangent of 21 is just a number, just a ratio. So I'm going to divide it out, divide by tan 21 on both sides, which gives me C equals 41 over tan 21. To find the length of C, I'm going to type that into my calculator. So 41 divided by tangent 21. And that tells me C is 106.8. Final answer. So your calculator gives you the decimal approximation of the ratio between the sides for any known angle. One more concept before we're done. Angle of elevation. The angle formed between the horizontal and the line of sight to an object above the horizontal is called the angle of elevation. So say I have some object up here in the sky, maybe a bird, and I'm looking from down here on the ground. The angle formed between the horizontal, so horizon, horizontal, and the line of sight to the object, looking up to the object, that angle is called my angle of elevation. Up here is my beautiful bird. So how is that helpful to us? Well, let's see. Mr. Rust is a huge fan of Hope Solo, the U.S. goalkeeper. One day, he gets to try and score a penalty kick against him. He figures that he'll aim as high as possible to go over her head. He kicks the ball from 36 feet away and with an angle of elevation of 13 degrees. Will the ball go in if the goal is 8 feet high? So in other words, we want to figure out if he actually hit it higher than 8 feet or he hit it exactly 8 feet. So he kicks it from the ground, up into the air, angle of elevation of 13 degrees. He was 36 feet away from the goal. So that's on the ground here. If this is my goal, we hope that he made it. Yomp. Not a very good goal. That's okay. He was 36 feet from the goal, and we want to know what the opposite side is, how big this is to know if he got it into the goal. So actually, I'm going to give that a letter just to keep track of it. So, SOHCAHTOA, that's where we always start. And what sides are we looking at? So from this 13 degrees angle of elevation, I have the adjacent side, and I have the opposite side. So needs opposite and hypotenuse, don't have hypotenuse. Cosine needs adjacent hypotenuse, don't have hypotenuse. Tangent needs opposite adjacent, I do have both of those. So I'm going to start with that. So tangent of my angle, in this case the 13 degrees, equals the opposite side, that's the x, over the adjacent side, that's the 36. To get the x by itself, because it's on the top, I don't need to multiply by x, I just need to multiply by 36. So I'm going to multiply both sides by 36. So I have 36 times the tangent of 13 is going to equal x. Type that into my calculator. And that tells me, oh no, Mr. Bush shot it at 8.311 feet. So will the ball go in the goal? No. Goes over the top. Too high. Poor Mr. Brust. All right, 2 questions for you to try on your own. Then come back and see how it went. Find, just in the first one, write the ratios, sine, cosine, tangent of angle A. And in the second one, actually solve for the missing side. So there's your answers. Pause your video for a minute if you need time to check your answers. Then go ahead and write your summary. Try out the homework.